Integration. You can consider integration as the inverse operation of differentiation. And you can consider indefinite integral, there's no range, definite integral, or improper integral. Improper integral is like integral is infinity or the range is infinity. Definite integral is from a to b. There's a range from a to b like this. And you can see the integration is, for example, fx is integration of f small fx dx. And it actually, this is the derivative. And the integration result is f big Fx plus c. And indefinite integral, it can be a Riemann integral for simple dimension, and you have another different way of doing the integration. Basically, it's the area of under the curve. It's just a two-dimension situation. So integral is like this, and you have a limit when you divide the infinity part. So this Riemann integral is actually involved in the real analysis, is the area under the curve. However, there are Lebesgue integral. There's a difficult part for Riemann integral. It's difficult to expand in the higher dimension, depending on the continuity and the limit process. So you can use the Lebesgue integral, so you can do the measurement of volume and something like that. Okay, this is the definite integral, and you can see it's actually area under the curve. And these are the example, one of the example. And the property of definite integral. For example, fx plus gx, and you can take it out and become plus and multiply by a constant. And these are the example. And you can see this, there are different type of the integrand. Even function, odd function, periodic function, something like that. And these are the example. And these are some of the example for your information. Later on, I will give you more. And these are more example of how you can do the integration. And these are more example. This called integration by part. So this integration by part is type of method to get the integration. And you can also get the reduction formula for the integration. So there are, first you change variable, that's one method. Then you integration by part. Then you can use reduce formula to get the integral. And there are some other different way you can differentiate integral and to evaluate the integral. So these are inequality for the integral. Okay. And is this there, and the mean value theorem of the integral. So the value is between the highest value and lowest value. And mean value theorem 2 is listed somewhere here. And you have a important application. These are example. Improper integral is if the if the integral have an infinity range, for example 1 to infinity, and you can do it this way. And another thing is integrand is infinity. So these are a couple of the examples when the range is infinity. And there's a simple test for conversion, and these are example. And another is integrand is infinity, and these are the example. And these are more example. And these are sometimes if you add them separately, it doesn't exist. However, it do exist if you add them together first, then get the limit. So this is a Cauchy Prince value, and these are the example. Then these are more example of integration, and these are more example of integration. These are more integration examples, and these are more example, and these are more example. And this just show you some graph. So for the previous integration, and you can see the graph look like that. And this last example. Now I will give you the formula from the book, and like this formula contain a plus bx, or formula contain a squared minus x squared and square root. So these are the form. These are the formula. These are formula. More formula, and formula involve ax squared plus c, and formula involve this, and more example. Formula involve this, and I will just scan through all this, and you can get this from books or from internet. So when you are doing integral, you actually don't need to really go through. You just get it from book or get it from internet. And algebraic form.